So number 15 is an in and out question. Okay, so the first thing we need to find is our initial values. So it says initially it holds 1,200 gallons of water. Okay, water is being pumped into the tank. So this is going to be my in, and water is being removed. So this is my out equation. So part A it says if the amount of water in the tank is decreasing at t equals 15, why or why not? So in order to find this one, we need to find how much water is in the tank, or we need to find the equation of how much water is in the tank. So I'm going to call that T for tank. So the water in the tank is going to be my initial amount plus the water going in. So I have from 0 to 15 of WT minus the water going out of WT. Okay. And then I have to take the derivative. Okay. So my derivative of 1200 is 0. The derivative of an integral, we're going to call that the t. The derivative of an integral, remember when you take the derivative of an integral, fundamental theorem of calculus, they cancel, and we're going to substitute the t. Okay. So then I'm just going to see what my value at 15 is. And that turned out to be a negative 121.09. So because the derivative is decreasing, okay, the amount, they said that the amount of water is increasing. No, it is decreasing at t equals 15. Another way you could have done this, okay, is find out how much water is being put in, how much water is going out at 15 for, the rate gallons per hour, and see which one's bigger. And you'll see that more water is leaving than going in at that particular moment in time. So part B says, to the nearest whole number, how many gallons of water are in the tank? So we're trying to find the number of gallons in the tank when t equals 18. So we're going to use my first equation that I wrote, because that is how many gallons are there in the tank at any moment in time. So it's going to be 1200 plus from 0 to 18 of WT minus R of T. And that is 1310 gallons. So 1,310 gallons. Okay, part C says, at what time from 0 to 18 the amount of water an absolute minimum? Okay, so here's the thing. Since we have endpoints, we have to check our endpoints, and this is very important. So first we're going to set the derivative equal to 0. So that's W of t minus R of t is equal to 0. So on my calculator, I'm going to see where they're both the same. Okay. And that's going to occur, the point of intersection is t equals 6.4948. Okay, so remember on your calculator you want to save this. So what I'm going to do is I'm going to do a table. Okay, up from 0. Okay, there's 2. There's t equals 6.4948 and t equals 12.9748. So I need to check both of those. I want to set 6.49, 12.97, and I also need to check 18. Okay, to see which one's the minimum. So at 0, there was 1200. At 6.49, so what I'm going to do is I'm going to find t of 6.49, put that in my formula, and that turns out to be 525.24. I'm going to do the same thing for 12.97. I'm going to substitute that into my equation, and that turns out to be 1697.44. And at 18, I already found that out in part B, which was 1310. So my absolute minimum, remember absolute means the lowest of the lows, so that's why I had to check my endpoints, was 6.49. So it occurs, my absolute minimum occurs when it's 6.4948 and the absolute minimum amount of gallons in the tank is 525.24 gallons. So part D says, for T greater than 18, no water is pumped into the tank, but water continues to be removed at a rate of RT until the tank becomes empty. Let K be the time at which the tank becomes empty, right? But do not solve an equation involving a coefficient that can be used to find the value of K. Alright, so the tank in the water, okay, the water in the tank started off with 1200, right? We're going to add water up to 18, and we're going to subtract the R of K. But we don't know how many hours we're going to keep that because it's going to keep pumping until the 18th hour. So we're only adding water up to the 18th, but the water is going to be pumped until we don't know when. And we want the amount of the tank to be 0. So it says to just write the equation, but I don't have to evaluate. We'll change that so the variables can be the same. Okay. Dx. And that would